Hi, everybody. I'm Mike,
And I'm Eric.
and we're here to provide answers to frequently asked questions about using Euresys products. Today's question, Eric, is how can I check the power usage and connection speed of the camera or cameras connected to my Coaxlink board?
In order for the frame grabber to provide power to the camera, the frame grabber needs to be connected to the power harness, the PEG connector, which can be found in most of the power harness you find on ATX power supplies.
Why is it, though, that I can't use power from the PCI Express slot to power the camera? Why do I have to use the PEG connector?
In fact, there are two reasons. First, on the PCI Express slot, which we use to connect the frame grabber in, most of them are limited to 25 watts. As our frame grabber uses about 15 watts, this leaves only 10 watts available for the cameras that could be connected to the frame grabber. We have decided to go with an external power supply, which enables us to provide for each of the connector up to 17 watts. And this is highly over the rate of the regular PCI Express slot power usage availability.
Wow, that's a lot of power. Okay, that makes sense then. Now, how can I see how much power I'm providing to each of the camera or cameras that's connected to my board?
Okay, let me switch to GeniCam browser. In GeniCam browser, you can see here under the category inside your interface, the category which is called interface control, you can see that the connector is the PEG connector has been properly plugged inside the frame grabber. So you have a 12 volt OK. And here inside the Coax Express category, when selecting all here for this, you see the overall power which is provided by the frame grabber. So we are providing here about 20 watts in total to all my cameras, which I've connected. So I've connected four individual cameras. And by choosing here various connector, for instance, here I've connector A. On connector A, I'm providing 344 milliamps over 24 volts, which is, I'm providing here 8 watts. Okay, here on connector B, I'm providing about 5 watts. And on connector C and D, which are about the same camera, I'm providing about 3.5 watts for a total of 20 watts, which is provided through all those connectors. Now, concerning the speed, we have another selector here which enables you to check for each of the connector at what speed this connector is provided to the camera. So on connector A, we see that there is a Coax Express which is detected, and it's detected at 6p6 speed. And I can select here connector B. I see on connector B it's 6p2. On connector C, it's connected in 6p3, and on connector D, it's connected in 6p5. So you see here I have 4 different cameras, and each of these cameras is connected to a different speed, which is properly handled by the frame grabber.
Great. So now I know that when I have in this case, 4 cameras connected to my board, I'm able to acquire data from all 4 of those cameras. How can I know for sure that I'll have enough available bandwidth on the PCI Express bus to get that data to host memory?
So we have another category which is called PCI Express here, which provide the connection status of the frame grabber. So here you have the speed which is supported by the frame grabber, which is Gen 3. Okay, and I can see here that the motherboard provides Gen 3 speed to the frame grabber. So this is perfect. Now I see that this particular board uses 4 lanes, and I see also that the motherboard provides 4 lanes. So this is the optimal configuration where everything which has been required by the frame grabber is provided by the motherboard. Now, in some cases, either the speed or the number of lanes might be less than what the frame grabber requires. In this case, the frame grabber will still operate properly, so will be operate to see all the camera and so on, but at a reduced frame rate. So you might have not enough bandwidth to send all the data coming from your camera to your PC memory if this, either the speed or the number of lanes, are lower than what is expected by the frame grabber.
Okay, great. So in this case, I see my Coaxlink Quad G3 board is plugged into a PCI Express bus, a Gen 3 slot by 4 lanes. How much actual bandwidth in terms of megabytes per second or gigabytes per second will this allow me to transfer?
In theory, each link is providing 1 gigabytes per second, roughly, 1 gigabytes per second. So 4 links is 4 gigabytes per second. A Gen 2 would only provide 500 and a Gen 1 about 250. So I have here in total, and this is in theory, 4 gigabytes per second available bandwidth. And out of these, most of the time with adequate memory, we can use 3.4, 3.5 gigabytes per second out of the 4 gigabytes per second available bandwidth.
Great. Okay, Eric, thank you for those answers.
You're welcome.